In the Web 2 world, basically you get your data from database, which is much faster, right? So when you are saying that Web 3 is going to replace Web 2, this is the problem you have to solve. It is all the tokens created on the Ethereum network, okay? And it's huge. Welcome back, aliens. My name is Navin Reddy, and in this video, we'll try to solve one of the problem which is there in blockchain. Now, we all know the power of blockchain, right? And that is trust. So basically, we use intermediaries for everything in the Web 2, right? Basically, if you want to do banking, we use a bank in between. Of course, that makes sense, right? Because the word is bank. But then when you want to do a transaction, if you want to sell something, if you want to buy something, if you want to update your details, your personal details on any website, basically everything is a transaction. Even when you post something on Facebook or Instagram, that is a transaction. Now, in the current world, we store all this data in the database, and what you see is the current value. What we want is the transaction history, and the history should be immutable. That means no one should be able to change it. And that's what is provided by blockchain. And we know the power of it, the way it is getting implemented in multiple sectors. It can be NFTs, it can be finance, it can be healthcare, supply chain. So basically we are using this solution, which is blockchain, for the problems which we had before, right? So there are a lot of technologies which is changing your daily habits, right? The way you work. Now, with blockchain and as with other technologies, there is always some drawbacks. Now, these drawbacks we try to find because if something is good, we see, can we use it everywhere? And that's where the problem starts, right? So blockchain is great, but then it's not for every problem. Yes, we are saying that we are moving from Web 2 to Web 3, but then it will take some time. And also at this point, we are trying to merge Web 2 and Web 3 together. Okay, let's talk about the blockchain problem. We have multiple issues here. So I'm using this particular slide from DataStax, and they are highlighting good points here. So let me go with it. So basically, there are some challenges with blockchain. So one of the challenges we have is with the performance. Now you will say, okay, what with performance? See, blockchain writing. So basically, when you talk about blockchain, we can save data and we can retrieve data, right? With any database as well. Now with blockchain, if you want to write something, now since we want to maintain this ledger, even that too on a decentralized network, that means no one is owning it. Of course, we need miners, we need some protocol to maintain the consensus, and it will take some time, right? If we talk about Bitcoin, it uses POW, and basically you have to wait for 1 hour for finality. Example, if you do a transaction, you can't confirm the transaction for next 1 hour minimum, right? So that's the average we take of 6 blocks. So again, for writing, it takes time. How about reading? Even for reading, it takes time. The next problem we have is data inconsistency. Now, this problem arises when you have a new block just mined. And as I mentioned, you have to wait for the confirmation, right? Now, depending upon different blockchain, the waiting time differs. Example, in Bitcoin, we have to wait for 1 hour. So that's one issue. And also, if there are multiple blocks mining at the same time, you'll be having multiple branches, right? So we have to choose a biggest chain. Again, that is also a problem of finality, right? So at a given point, if you have a new transaction which just happened, you're not exactly sure is it confirmed or not confirmed, or is it still available on the blockchain because we have multiple chains. So you're not sure on which chain the data is going to. So basically, let's say if you want to say blockchain takes time, of course, right, for writing and for reading. When it comes to writing, the number of writes we do is less than the number of reads we do, right? Like if you talk about any application, it can be, let's say, Instagram, or it can be banking application. You normally try to see the data more than you write data. Example, you go to Instagram and you see other people's post. So the number of reads is much higher than the number of writes. Now in blockchain, writing is slow is because we have to wait for the finality. And of course, we have a private solution as well, like Hyperledger Fabric, which is much faster because that's a private network. But still, it's okay if it takes time to write. But it's not okay if it takes time to read. Now, why it will take time to read? Now, let's say we have this big blockchain here, and now you want to search something. Now, first of all, you don't know which block will have that data. Of course, right? After every 10 minutes in Bitcoin, basically you are creating a new block. And now if you want to search something, it will take time. How much time? It depends, right? So let's say you have 1000 blocks and then your data is there on the 555 block. You have to basically search for the first block. It will take time. And in the Web 2 world, basically you get your data from database, which is much faster, right? So when you are saying that Web 3 is going to replace Web 2, this is the problem you have to solve. Especially people who are working in the Web 3 environment and they are building dApps, which is going to read data from the blockchain. Imagine as a normal user, if you want to search something, your blockchain or the dApp developer application or your dApp will say, okay, wait for a few minutes, we are getting your data. No one have that patience, right? We want the data instantly. So how do we solve this problem? So this is a problem, right? So when I say performance, this is a problem we are trying to solve. Next, the solution for this would be, what you can do is, in fact, most of the companies are doing it. They are basically trying to create a database from the blockchain. So what they do is they take a blockchain and then they try to copy data, or we can say offloading data. So they offload the entire data in a database. It can be MySQL, Postgres, or any database for that matter. And that data is available in a database. Again, example, let's say if I'm a dApp developer, if I'm building an application and my application need to search data on the blockchain, basically, I have to copy the entire data from blockchain and store that on my server. And next time when a user tries to fetch data, basically I will search the database. I don't have to go to blockchain to search data because it will take time. The problem with this is it will consume a lot of data and you have to bear the cost. Next, in fact, the cost is very high is because you need huge amount of storage because Ethereum blockchain itself takes around TBs of data, right? Next, we have a complex infrastructure because you have to maintain that, right? You will not have one server. If you want to give a good experience to the user, you have to make sure that your database server is up and running continuously. For that, you have to also need a backup servers. Managing them will be difficult. Also comes the skills. The thing is, all the data which is stored on the blockchain, basically, most of the data will be encoded or it can be in hexa format. You have to basically decode the values. So of course, you need certain expertise to do that. Maybe you have to hire someone to manage it. So, but basically you need experts to handle that. And also the part of security. If you are storing all the data in the database, you have to also make sure that you maintain the security. Anyone can hack it, right? So basically the ultimate thing which we're talking about is the performance here, and companies who are trying to implement their own solution, they will face this issue. And most of the companies are doing that, okay? They are offloading the data in their own databases. The next problem we have, or next thing we have here is called a blockchain dilemma. Now, basically, if you heard about the database concept, example, if you want to make a scalable database in the Web 2, we have to go for CAP theorem, right? Where you actually cannot achieve all three, you have to go for two, right? Either C or P or C or A or P, right? But when it comes to blockchain also, we have the same problem. So we are trying to achieve decentralization, right? That is confirmed. Next, we are trying to achieve security because of course you want your data to be secure. But we also want to make sure that your application is scalable. Now, can we just combine all these three? Now that's difficult. So you can achieve decentralization and security. You can achieve security and scalability, but not all three. So how do you make your data scalable, or how do you make your application scalable? So to understand that, let's go with this architecture. So basically what happens is in the Web3 now is whatever data you are working with, basically you have a blockchain and then whatever data, so your application writes some data, right? So example, there's a transaction or someone is changing something, you're selling something, you're buying something. That's a transaction. So basically you write data. But now what if you want to read? So you will read from the same blockchain. The problem is it will take some time. So to solve that problem, what we can do is, so we have a solution here, which most of the companies are doing it. So what they can do is they have a blockchain there, right? So whenever they write data, the data goes into blockchain. We cannot change that because ultimately we want to use blockchain. But when it comes to writing, what we can do is, from the entire blockchain, you will extract your data and store that in a database. It can be any database as I mentioned. And then you can basically read from that particular database. We have talked about the same thing, right? Now here's the change. When it comes to your database, we have to make sure that your database is also scalable. You have to also make sure that your database is also accessible continuously. So one of the best database concept or NoSQL database here we can use is Cassandra. In fact, I have already made videos on Cassandra. You can check that out in description. Basically, it's an awesome database to work with, is because it provides you a lot of different features, including partitioning, the speed, and the uptime. So I'm talking about Apache Cassandra. Okay, so we can use Apache Cassandra. So whatever data you are getting from the blockchain will be stored on the Apache Cassandra, where you have multiple nodes. Already you have a backup, right? So it provides you best solution there. Now, if you want to use a cloud service, if you don't want to do all the setup on your machine, because again, as I mentioned, right, we have a cost problem, we have a security problem to manage it. Basically, we have to deal with the complex data which you have to handle. So we can use a cloud service for the Apache Cassandra, which is DataStax Astra DB. So basically, whatever data you are getting from the blockchain will be stored on Astra DB, right? Now, Astra DB was not having this feature before because it was just for data storage. But then they realized, hey, blockchain is booming. So can we just also create a solution for people who are facing this issue? Can they just offload all their data in the Astra DB? And to achieve that, we got this amazing tool or amazing platform called Astra Block. So let's understand first how it works, and then we'll see an example as well. So in this particular session, we are going to see theory and the practical as well. So if we talk about Astra Block, let's understand how it works. So whenever you have a new block which just got mined, okay, the moment you got a new block, because see, we want the current data, right? That's how you can maintain data consistency. The moment you got a new block mined, so what it will do is the Astra indexer, Astra blockchain indexer, it will simply receive the event. So once the indexer receives the event that it happened, a new block is created, it will try to process the block. And after the processing the block, it will copy the data in the Astra DB. That means the moment you have a block mined there, you will be having the data in the database. Now, it does that with the help of CDC. Basically, it will wait for the change. The moment there's a change, it will copy the data. And then the data, as I mentioned, will be available in the Astra DB instance. And now, as a normal developer or your dApp, basically can use that data from the Cassandra. And also, it's not just for one blockchain. Of course, initially they started with Ethereum, but in future, we will be having multiple blockchains, right? And it's not just you can copy data or you can get data from one blockchain. If it can work with one blockchain, it can work with other blockchains as well. So it will copy the data using the blockchain API, and it will index it, and it will be available for you to use. You can use that data for machine learning purpose. You can use that data to create a microservices which can be used by other apps or APIs. So yeah, it's an awesome solution. But then how do we use it? Now, the good thing is they will give you a free account if you want to use it, and also you will get some credits to use. Okay, now how do we use it? So first of all, you have to go to Astra DB. So this is the website. You will get the link in description. So basically, if you don't have an account, you have to also make sure that you sign up first, and then you will get the account. I already have an account here, so I will log in. Okay, so login done. Okay, so basically this is your homepage here. Now, as I mentioned, they have introduced this service recently, which is Astra Block. And you can use this service. The only thing is, initially, if you don't have the access, if you don't see this option here, you need to request for the access. And I will give you the link in description. How can you request for the Astra Block access? It's not for everyone at this point. You have to request, and the internal team of DataStax will give you the access. Okay, so basically, I want to create a database here. Now, this database, which is a Cassandra database, will be fetching the data from the Ethereum blockchain. Right? Now, to create a blockchain database, you can simply click on this clone blockchain database, and they did some recent changes in the UI, so you get this option here. Now click on the clone blockchain database. So what it will do is it will clone the Ethereum data or all the transactions in this particular database. Now you have to select which blockchain you're working with. So at this point, you have two options only with Ethereum. In future, they're going to add more. So you have an option of creating an empty structure. So basically you get the structure, and then you can stream the data. But we are going for complete data set here because I want to create a database which will be having the complete set or all the data. So I will say complete data set. And the only thing is when you say clone, it will take hours to clone because on Ethereum, we have terabytes of data, right? Okay, so what name I want here? So I will say this is my Ethereum. And then, of course, you can use any database name. You can also say Ethereum DB. I will just go for Ethereum. And then you have to select a cloud provider. Now for free service, they provide you Google Cloud or Amazon. I will go for Amazon. And here you can select the region. I will select US West 2. And that's it. You have to agree the terms and conditions and click on clone. Now the thing is, I've already done this step, and as I mentioned, it will take 5 to 6 hours. That's what it took me a few days back to get the data. But let me know in the comments how much time it took you for cloning the database. And as I mentioned, it's huge. Ethereum is huge. So I will close this because I already have a clone database here. Or let me try, if I say clone, what happens? Okay, so it says database Ethereum is cloning, okay. But as I mentioned, I already have the Ethereum database created, and this is a new one which is happening now. What I will do is I will just cancel this. Okay, I will delete that later. So I will go back to my dashboard, and you can see I already have two databases here. One is now created, and the first one I've created this way back, and you can see the size of Ethereum, 2 terabyte. So it will take some time. Now this is already done. I have done a lot of experiment with this particular database, and I have requested a lot of data. And this is the Ethereum database we have. I will click on this. After everything is synced, you will see this active symbol. If it is syncing, maybe you will not able to query your database, but yeah, you have to wait for it. So you can see for me, it says active. Okay. Now it provides you this UI where you have the number of reads, because I've already done that. And we are not going to write anything in this is because we are using this for reading data. If you want to write something, you will do that on the blockchain itself, right? Now remember this, there is a region section here where you have this data on the AWS. Region is US West 2. And we also have a data center ID, which we're going to use later. Now, if you want to use this, basically you also need a token. So when you click on this, in fact, I will show you how to create a token, but you have multiple options here. You can check the health of your database. You can connect with the application which you're working with. So you can see there are certain steps which I'm going to see later. And we also have an option of CDC for syncing. You have to make sure that you enable CDC, because I've disabled this because I wanted to make sure that I don't lose my credits. And so you can just mention which key space you have and which table you want to sync. So I just want to sync one table, which is tokens. Again, I will show you how many tables you have. I will just enable CDC. Okay, something went wrong. We'll check the table later. So let's go back to CQL. Now CQL stands for Cassandra Query Language. So basically you can write queries to see data. Because at this point, if you want to fetch something from the blockchain, you need to literally write an application to offload data and search in the blockchain. Of course, you can use certain tools, the libraries which Ethereum provides, or you can use Web3.js or Ether.js to do that. Let me increase the font size a bit. Yeah. So basically, this is a place where you can query your data. Now, first of all, I want to see which database we have here. So basically, we have the key space name as Ethereum, and I will say use Ethereum, and I want to see how many tables we have. So if I say describe tables, so you can see we have all these tables available here. So we have assets, which will have all the assets on the Ethereum blockchain. Then we have logs. If you want to monitor the logs, we have tokens. You can also get dashboard analytics. The way you have on Etherscan, example, when you go to Etherscan, you see all the graphs and analytics of the blockchain. You can also get that data from the dashboard analytics. And then we have all the contracts available here. You have all the NFTs available here. So if you want to search for a particular NFT, you can just fire a query. Example, let's say in this particular example, we are going to focus on tokens. So what I will do is I will say describe tokens, and let's see the table structure. So basically this is a table here, and the table name is tokens. So we have a token address, we have a block number, we have a block hash, in which block number this token was created. We have the block hash as well. We have timestamp, we have decimal it support. Then we have name, symbol, and the total supply. And for this particular table, the primary key or the partition key is this address. So we are going to use address to fetch data. Now, if you want to see the data, if it is really synced, what I will do is I will say select star from tokens and just wait and see the data. The moment I say enter, you got all this data which is there on the Ethereum in this database. And look at the amount of data we have. It is all the tokens created on the Ethereum network. Okay, and it's huge. So let's say if I want to fetch a particular token with an address. So basically which token I want to search with. So let's say we have all this data here, and I'm interested in the wrapped ether. So if I search for wrapped ether token. So yeah, so we got wrapped ether, which is a token here. And then if I copy this particular contract address, so I want to copy from the address. In fact, you can also search by the token name or the symbol But let me just go with the address here. So I will say select star from tokens, where the address, that's the field we have. Address is equal to, and just paste it here. Okay, so when I'm copying it, it is becoming capital. It is small here. Okay, it's case sensitive, so I'll just get it from the transaction hash. Yeah, that's the token. Copy. That's the contract address. Copy, and let's paste once again. I hope this time it will not be auto capitalized. That's better. Enter. And you can see we got the details about the wrapped ether. So when you search for a contract, you get all the details. You get a block number here, you get the hash, you get the date timestamp as well, and you get wrapped ether here, which is a name, and you get the total supply as well. So basically you got all this detail, right? So what it does is it copies it offloads the data from the server or from the blockchain to the Apache Cassandra, that too on the Astra DB here. Okay, this is great, right? But then how do you connect this to your application? So of course, as a developer, let's say if you are into Web 2 or Web 3, how do you connect with this? Now, since we are still into Web 2, let's try to explore this. How do you get this data in the Web 2 world? So what I will do is I will click on connect. So you can build any kind of application. Example, if you go here, you can request for REST API, GraphQL, or document API. But specifically, we are building application in Java now. So I will click on drivers. And you can see we have 5 drivers available here. We got for Node.js, we got for Python, for Java, for C++, and C#. So we are going to go for Java, and the steps are here. Basically, if you want to use Java, you just need to get these dependencies, and these are the code. But I'm not going to use this particular code here. We have some structured code available. You will find the code in the description. I will give a GitHub link, and you can just open that project and make some changes. I will show you what are the changes you have to make. But if you want to do that, you just need a token first. Now, in my machine, I already have a token in my account basically. But if you are doing this for the first time, you will get an option here, which is for creating token. So click on create token, and this will give you an option. Now, which role you want to go for, you can select here. I would say you can go for organization administrator because you will get every option there. So there will not be an issue. So click on generate. You will get your token here. Now the token I'm concerned about is this one. In fact, it's good to download the entire token details here. And don't worry, I will just delete the token once the video is published or before the publishing. So you can't use my token. Yeah. So what I will do is I will just download the token in case if I misplace it somewhere, or I will also keep it saved somewhere. That's my token. Okay, so let's fetch this data. Now what I did is, now specifically for this particular table, which is tokens, of course, you can use any data in the tables or any table basically. But for this particular application, you can see this is my project available here, which is Astra block, a Spring app. And as I mentioned, you can use any programming language you want. Now, I was comfortable with Java, so I did it. If you're comfortable with Node.js or Python, it's your choice. Now, if you want to work with this project, first of all, what you need is you need a Spring Boot app. So this is a Spring app. Basically, what you need is you have to go to the pom.xml file, because this is also a Maven project. You need to add this dependency. You need the DataStax Astra SDK. You need Spring Boot Starter Data Cassandra. And of course, you will get this project in the description link. And then you need a starter. And also, now since we don't want to build a UI here, just to keep things simple, what we have is we have a Swagger. So if you want to use Swagger or OpenAPI, what you say, the new version, you can just use this particular dependency and it will enable your project for the OpenAPI, so that you can just send the request and you will get the response. Okay, once we have done that, this is a dependency we need. Next, there are certain things you have to do. There are some setups you have to do. First, if you go back to your SRC and if you see this first application, you can see this is simple Spring application, nothing here. In fact, there's no particular code which is mentioned here. Let's skip that. If you go to your tokens, you need to first create a mapping class, right? Of course, we need to connect your Java application with database. So it's better to have an entity class, right? Tokens. Now we have to use certain annotations. You have to mention what is your table name in database. So in database, the table name is tokens. Here we are using token as a class name. And then you have to mention all the fields. So in the table, you have address, you got block number, you got block hash, you got timestamp, you got decimals. So I've created all these variables here. And then you can see we have some annotations to map your table and your class. And then this is simple Pojo class, you can say, right? You have data setters, nothing fancy here. Go back to controller. So what I want to do is I want to send a request with an address and I want to get the details from the blockchain. Now, since we're not using blockchain, I want to get data from the Cassandra, right? So I want to accept the user request. So what we have is we have a request mapping here. So a user will send a request with the address and will also pass the address here. Now that address, I'm accepting it here. And then we need to get the data from database, right? Of course, you don't have to write the connectivity steps and all those stuff. You can use the Spring REST here or Cassandra basically. So you can create a repository and you can extend a Cassandra repository because now you're fetching data from Cassandra. And you just have to mention which method you're going to use. So method name is find by address. Whatever address you pass, it will fetch the data. You don't have to write much code. And this data will be available to your controller. And once controller gets the data, it will check if the data is there. If it is empty, return no, not found, which is 404. And or you can say, okay, you got the data, send the response, and the user will get the response. But then nowhere we are mentioning the connectivity steps, right? I mean, how will you connect with the Astra DB? You have to provide some credentials, right? Now for that, you have to create a config file. Now in this config file, you have to mention few things. The first one is a token, right? Every user needs a token. And that's the token we copied. You need a token value. You need to also mention your database ID. Now, if you remember, when we went to this DataStax Astra, and when we went to the Ethereum, you also need to specify your data center ID. Okay, so that's the variable here. Next we have is database region, which region you're using. So we are using US West 2. So we are going to specify that. And your key space. So key space name is Ethereum, we'll use it. Now all this data is actually coming from a file, a config file. So if I go back to YAML file here, so we have token here, we have to mention the ID, region, and key space. Now the token, where is my token? I will just copy it from the here, Sublime, copy and paste. That's my token, saved. Next, we have to specify the data center ID. Okay, let's set it from the website. This is my data center ID. Copy and paste. Next, we have to mention the region, which is this region. So copy and paste it here. Then we have to mention the key space which is Ethereum, right? So you have to mention this detail and you can use this project. So what are things you need in your project? First, you have to make sure that you have a DataStax Astra account. You will find the link in the description to get the account. You have to make sure that you create the database to clone the blockchain. And first you have to send the request. Then once the syncing is complete, you have to make sure that you generate the token. Now you can run the application, right? With this, you also need this particular file, which is com file, to increase the timeout, because by default it gives you, I guess, 5 seconds. We made it 10 seconds so that it will wait for some time. Otherwise, it will give you timeout error if you don't do that. And that's it. Once you have your project ready here, what I will do is I will just run this project to see if this works. Let me open my application, right click, run Astra DB or run Astra block Spring app project. Now it will take some time because there are a lot of things happening. First, it is running the project and okay, there's also a lot of things happening. You got the error here. Okay, by mistake, did I deleted any code from here? Okay, so it says database, this is the main problem. Database, this not found. So I think while copying it, I made a mistake. So we got 1 at the end. And my data center ID is this. Okay, is this one extra? Let me just check once again. Okay, this is my data center ID. 8240, this, 36. It should end with 36. Okay, so I guess -1 is extra. Okay, so you can also confirm with this particular link. You can see from here till here, that's your data center ID. This is your region, and yeah, that's the things you need. That's my ID. It's already mentioned here. Okay, cool. No problem. I will just run this code once again and to see if this works. Run. Yeah, so as I was talking about, it will take some time because it is loading your Spring Boot app, which is a web app. It is trying to connect with the Astra database and connecting. So it will take some time, around few seconds. And once everything is done, in fact, it also downloads the token details. So basically, if you see, we are also specifying that we should allow the downloading of the token. So you can see in the code for the SQL session, we are enabling the download secure connect bundle. So it will download the bundle, which has all the credentials of yours, and then it will load it so that it will maintain security. Okay, so it says it has loaded on the particular URL. Now to go there, what I will do is I will say localhost :8080 and then /swagger-ui.html. Now this is where it will load the Swagger. Now since it is, we have enabled the open API, you got this layout. Otherwise you have to create a UI as well. If you're good with UI, try that and let me know the code. In fact, share your code in the comments. I will just use it for my next video. Okay. So you can see we got tokens here and I can just fetch the address. If you want to try it out, click on try it out and paste the address. So we already got the address. I will just copy this for this particular token, paste it here and execute. And you can see we got the details. So we got the block number, we got the block hash, and since it was fast is because it is coming from the Cassandra database and it provides you 100% uptime. It's not fetching data from the blockchain because it will take some time. Okay, so yeah, so that's how you fetch. So try this out. You will find the link in description and let me know in the comments what extra you did with the different tables you have. You got tokens there, which we have used. You also got asset. You also got transactions. So try it out and share your code. But the basic code of this, of course, you can make the changes here. We have done for the token. You can do for the transactions, asset, and yeah, share the link in the comments. I will make sure that the favorite one, I will pin it in the comments so that everyone can try it out. So that's it from this video where we talked about the details of Astra block.